Different programming languages have their own ways of working with relational databases and SQL. For example, Ruby on Rails has Active Record, Python SQL Alchemy, TypeScript Drizzle, and so on. Go, being a language with very diverse standard library, has database/SQL package, as well as other libraries and solutions for working with SQL that may suit different teams, preferences, and needs. Database SQL was built with simplicity in mind, but it also supports all the necessary functionality you may need working with SQL in Go. For example, prepared statements, transactions, managing connection pools, and so on. As long as you're comfortable writing your own queries, parsing and handling the results, it's a great option. And as a matter of fact, it was my favorite option for some time because there is no hidden logic there. You can just copy and paste your query from your Go code to your database client and run explain, and that will be it, right? There is also no performance overhead, so it's a great option, and it's also in the standard library of Go. There are also great ORMs in Go, such as SQL Boiler and GORM. The difference is SQL Boiler is schema first, so you define your schema, then it generates the code for you. While GORM is where you define your models as Go structs first, and then write some code, and then it generates the migrations and schema for you. But as you may already notice, I'm not a big fan of ORMs, so I won't dive into them today much. There is also a great package called sqlx. I believe X goes for extensions or extended, which is built on top of standard database SQL and just extends its features. So if you like simplicity of database SQL but want to reduce some boilerplate code, sqlx is a great option. And let's have a look. It exposes a few really helpful small functions like get and select and many more that simplify how you unmarshal the SQL results. For example, get would unmarshal a single row into the p variable of type place, and select would do the same but into the array of places in a single line of code. In database SQL, for example, you would do it using the loop and calling row.scan in the loop, and you may hit some errors where there are nullable fields because you need to use sql.nullString and so forth. So sqlx really reduces the boilerplate and keeps your code still simple. And it's also a drop-in replacement for database SQL because this object db, for example, in this case, it implements the sql.db interface that we are used to. There is also sqltx, so it's very easy to change your current code that works with database SQL to use sqlx. That brings us nicely to my favorite approach of generating Go code from SQL schema and queries. The project is called sqlc, and it basically generates the type-safe Go code for your queries. With sqlc, you still write your schema and queries yourself, because why not? SQL is great. But then you use a CLI command sqlc generate to generate a Go code for your queries. And so it generates models for your schema, functions for your queries, with input and return parameters as proper Go types. Also ensures to some extent that your queries are syntactically correct and type-safe. Why I say to some extent? Because obviously, sqlc tries to predict what the types of your schema, looking at your migrations, for example, but it's not always possible. So it can generate some interface types if your schema is really weird, but in most cases, it works just great. Okay, enough talking, let's dive into it and see it in action. And I think the best way would be to introduce sqlc to existing project with existing database migrations and queries. And this project came to my mind. It's called Formulosity. It's a small project of mine. It's self-hosted services code platform. So there is nothing fancy there, but it uses database SQL to work with databases in Go. It works with two databases, so SQLite and Postgres, and you can switch between them. But for this example, let's focus on Postgres only. Okay, let's install sqlc to our machine. I'm using Homebrew, so that will be my command, but it's also possible to install it using go install and Docker and snap, and maybe there are some other options. I'm already inside my project, but let's create a branch so we don't lose any changes. And let's explore the project. So I mentioned that there are migrations already. They've been created using Golang migrate project. There are two types of migrations, SQLite and Postgres. They're basically the same, just in different dialect. If you open up Postgres, it creates different tables, different types, and there are the same migrations for SQLite, but let's not focus on them. And there should be somewhere code that basically works with these tables, runs some queries. So I believe that should be in the storage package and Postgres. As you can see here, it uses database SQL. It needs the database and where the queries. For example, that's your normal query to create something in the table using database SQL, right? You write your query as a string, you do maybe .query row or maybe exec, just query. So there are multiple options here. And yeah, it's not maybe the best looking file, but that's how you work with database SQL in Go. For now, I won't change any of those queries, but I will create sqlc version separately. So let's start by telling sqlc where to find the migrations and queries. For that, we need to create a file, sqlc.yaml. This configuration will be used by sqlc generate command. It's actually quite simple, and we just need to change only a few things here. Engine PostgreSQL queries. Let's start with schema first. So our schema is not in a single file, it's basically migrations. So I believe it's migrations Postgres. At the moment, our queries are scattered around this postgres.go file, so they're in line. But sqlc wants us to have queries written in SQL files. So we'll have to tell sqlc where our queries will be. I'll create them in a separate folder, maybe package db queries, right? Now, if we go to Go part, that the package will be also called database, and out will be package database. Don't need to do that. SQL package property tells which database driver to use. And in this case, we use pgx, which is a really popular Postgres Go driver. Previously, people used lib/pq, but it's not maintained anymore, so pgx is the way to go. All right, let's save this file and try to run sqlc generate. Right, so we don't have queries yet. And first of all, let's create a folder for them. Let's copy some existing ones. So we go to Postgres. Maybe let's start with the creation of this service. So we'll take this query, and then we'll put it to package db queries. It's called service.sql. So there could be multiple files here, split probably by the table name. That's what I've seen works the best, but doesn't matter much. So we can keep this query as is. The only thing we need to do is give this query a name. So sqlc needs a name, and also tell sqlc what this query will return. So a name would be create survey, and what it returns is also a colon, and there could be here one, many, or exec. I believe only these three, but as you can see, we use Postgres returning, and it's a single row, right? Let's also return everything here. So then sqlc will use the full survey type. And maybe just to demonstrate some other queries. So name get survey. So this one also returns one. We can also use here sqlc arguments. So we can use arg and then uid and then give it a type, something like that. And let's also create a query that returns multiple rows. So names would be. Now with few queries in place, let's go back here and click sqlc generate. There is no error, it's very silent, it means all good. It would be great if sqlc would tell us where these files were generated and what was generated, for newcomers, for example. But as I already use sqlc, I know where to look for. As you remember, we told sqlc to put everything into package db. So that's easy, but then what was generated? These three files. Let's start with database Go, and let me run go tidy. So this file is quite short. It has some constructor functions that we'll need to use to initialize the instance of our queries type. That's where all the database functions will be. Let's open the models. So for each table from our migrations, sqlc was able to generate models and the code to parse these models. So this one is a little bit bigger, but let's look for something cool. So here's our survey table. It used PG type for UUIDs, timestamps, so very nice. And then other tables, right? And all the types and some functionality. And then we've also seen our surveys.sql.go, which actually, just inlined our queries and did all the parsing around them. So passing the input parameters, returning the proper type. As you can see, get survey returns this model type survey. Input parameter is UID. For the list of surveys, yeah, just returns the array, and there are no parameters here. It always passes the context, which is all good here. So very easy to use, right? You have these 2 or 3 functions that we created. Now with these files generated in our project, we can actually go now and create a database client and call these queries. And because I don't want to break anything in this project yet, I will create a separate main.go file where we'll test our changes. So actually, I already have the database up with the migration, so I can connect to it directly from here. Now, as we use PGX as our Postgres driver, we can use it to create our Postgres connection. Now, I believe that our connection should be closed in time, so we can do this using defer. And now we can pass this connection to our internal function that was generated for us, which is db.new and connection. And that would return a single object queries. And I believe on queries there will be, yeah, our kind of create survey, get survey, and get service. So let's start by creating one first. So we also pass context here, as well as parameters for creation. So I believe it's create survey params, exactly. They always call like that. If you have a function, let's say create something, the arguments will start with this query. So you always know what to look for. If your query is really simple, just needs one argument, it will be just in line here as kind of is the regular type. I'll show you later for the get survey. But here, because we need to pass multiple fields, there is this object. Let's pass some name, maybe test. Otherwise, we can print that survey is created. So survey created. What to pass here? Maybe yeah, just the whole survey. Now remember, there is a function to get the survey by UUID, so we can maybe try to use that. So let's call our last function, which is the list, right? So that will be Q. Let's quickly review the file again. So we established connection with our local Postgres instance. Here we create the queries object that was generated for us by sqlc. We pass the connection there, and then we call create survey, get the survey by ID, and then get the list of all the surveys. And I believe we can call this function as many times as possible and see some result. Right, we can call it with go run. Cool. Our output is not that great because it just shows the bytes of UUIDs, I believe. Also doesn't have new lines, but I can see all the messages here. So we created this survey, we got it back, and the length is 1. And that's the basic usage of sqlc. It's very simple. Now, if we go back to our queries, if you look at this code, it's really simple. It's straight up SQL queries with additional name and sqlc kind of arguments if you need it, which is also optional. You can just use our regular kind of $1, right? And then sqlc will be able to figure out that, you know, it's UUID of this type and all good. Sometimes sqlc arg is needed, also maybe for readability and for generating the proper types. What won't work is, let's say we try to reference some column that's not here. Obviously, the query won't work, but usually if you work with database SQL, you only will notice that when you run your code. The difference here is that you will notice it when you generate your code, because it already knows your schema, it knows what columns you have there, and it obviously knows that this column is not there. So there is some safety in that. Let's also have a look at our models again. Let's have a look at survey type sqlc generated for us. So the names are really clean, they match the column names, the types are clean as well. But sometimes you want to have a control of naming your types differently, or maybe using also different types for your structs. And that's possible in sqlc, where you can tell sqlc that for UUID, I want to use, let's say, this package and this type on this package, or maybe it's string, maybe it's integer. There are different variants here. So maybe database type to use something else. Then for the column, I want to use different type. Let's get back to our survey type. I know that parse status and delivery status are enums of type string, and maybe for simplicity, I just want to have a string here, and that's all possible. I want to keep UUID as is, but that was our column, right? So our column was named, it starts with the table name, so service, and then parse status. As I remember, we don't use anything like import, just want it to be a string. Let's try to generate the code again. And if we open our models again, right, as you can see, now it's simply a string. And you can use your internal types maybe if they're already defined, because sometimes you're working on the program and you already have structs defined, maybe as external package, maybe internal, and you don't want sqlc to generate all over again these types, so simply reuse them. The only thing you need to pay attention to is that it's serializable by the Postgres driver. If you open our main.go file again, we can see that we are not using transactions here. We call the database directly using the 3 separate queries, but generally it's nice kind of to use transactions, especially when you create something and then check that it exists, or maybe you insert multiple times. So it's actually quite easy to change here. So what we need to do is to create a new transaction using the, I believe, connection.begin with cdx. And then we already have this queue, but now we'll be using a different kind of, let's call it transaction queue. Will be called queue with tx, and then pass tx here, right? The only thing we need to change is, instead of direct query, call this tx queue. So here, here, and here. Then at the end we do tx commit. No, it's ctx. And so obviously we need to handle errors here, errors here. When we open the transaction, we also need interfere to roll back it. So tx rollback tx. Okay, I believe that's it. Let's run our domain again. Yeah, and it's all the same, but now using the transaction. So if something in the middle failed, we want to call other queries, right, and exit immediately. This is not the best use case that we have, but just to show that it's possible. In this example, we use Postgres, but obviously sqlc also works with MySQL and SQLite, and also different database drivers. I'm still a big fan of database/SQL standard library in Go, but I also find sqlc really nice. It doesn't introduce too much unnecessary complexity, reduces the boilerplate code a lot, and generally it's kind of nice to work with and makes your queries a little bit safer. And because we did all these changes in the branch, I will create a pull request and put it in the description as a link. And that's it for today. Thanks for watching, and put in the comments what you are using to work with SQL databases in Go. Bye.